Now I'm going to create a very simple policy. So I want to allow IAM list and read operation. And what I'm going to do is select all resources in here. Oops. So now what I've done is I've created a very simple policy which allows IAM list and read operation. So this is basically read-only access to IAM service. So what I'm going to do next is quickly modify this one, and I'm going to introduce EC2 colon star and DynamoDB colon star. So what I've done is I have added allowed EC2 full access. This is again whenever there is a star followed whenever there is a star which is following a service name, this is full access, right? Full operations, all operations can be performed. So I have allowed all access on EC2 as well as DynamoDB, and only read-only access to the IAM service. So next what I'm going to do is click on next tags, click on review, name this as Bob, and I'm going to click on create policy. Now the Bob policy has been created. Now I'm going to create a role. So this is to answer the question of Raiders again, are these policies bypassable? We cannot bypass as long as, again, we cannot bypass them. By bypass, we will be implying that there is some kind of mistake in the AWS implementation. So it is not the case. There can be misconfiguration which we can abuse. So what can happen is, again, the developers, administrator might not have imposed granular restriction, due to which an attacker can go ahead, steal information, perform other operations. I'm going to create an IAM role, and I'm going to mention that this specific account, all users in this specific account can assume this specific role. So I'm going to click on next permissions, and now I'm going to attach administrator access policy. Yes, a completely secure AWS account, we cannot perform attacks. We need to have any kind of misconfiguration or a vulnerable application which is running on the AWS cloud environment, and from there we can go ahead perform these attacks. If you are able to perform an attack on a secure AWS account, that means you have identified a 0-day on AWS environment itself. And again, AWS will probably award you like thousands of dollars for that. So next, what I'm going to do is I'm going to select administrator access policy. And I'm going to click on next review. I'm going to call this name of, or call this role as Bob. So this is to answer the question of Sleepy. Does anyone has one slider intro to AWS? Just something nice to go through to get familiar with all the technology, etc. I think I'm covering things from very basic, but in case if you're facing some difficulty, you can go ahead, look for the terms in AWS documentation itself. Personally, I feel AWS documentation is the best place to learn about all of these things. So they are well documented, and personally, I do not prefer to many of the third party blogs. Reason being, many times I have found that these blogs are sometimes little misleading. So I'll recommend going through AWS documentation. That's best place to learn. So now what I'm going to do next is create a role with the name of Bob. So next I'm going to click on create role. Now role Bob has been created. So can anyone tell me at this point what permission does Bob has? So at this point, Bob has administrator access, right? So let me quickly, and Bob can perform every operation on the AWS account. Now let me quickly go ahead, set a permission boundary. And I have created a policy called Bob. And we know that this specific policy allows full access to IAM, or sorry, read-only access to, this is again, read-only access to IAM service, full access to EC2 and DynamoDB. So this is again, full access, full access. Now here we can notice that manage policy Bob, if we'll expand this one, this says we have DynamoDB full access, EC2 full access, IAM full access. Now, in order to use this role from the AWS console itself, we can go ahead, click on this specific link. So as you can notice, we have uh, the option to perform switch role operation. So I'm going to click on this specific one, and we can set any display name. I'm going to select the color green, and I'm going to click on switch role operation. So at this point, can anyone tell me what all permission the user Bob has? Bob has admin. Does Bob has admin permission? Anyone? So we noticed that we had provided Bob or attached administrator access policy to Bob, right? But if we'll take a look at S3 service, so technically, due to the policy, we need to, again, this should be accessible, right? But we'll notice that it will throw an error. So can anyone tell me why are we getting an error at this point? Because we had attached administrator access policy to the user Bob, right? Yes, that is correct. So if we'll go back to the IAM service, now please note we have IAM read-only access with the Bob user, right? So if we'll go to the roles and check the permission of Bob, let me hide this one. So this specific policy says that, okay, administrator access. And basically it says that, just a second. Oh, it's going to be a very long list. Let me quickly hide this one. Yeah. So if we'll expand this one, you'll notice that it is a very long list. And it allows all of the services, right? Full access, full access, full access, full access. Now, but the important thing to note here is we have set a permission boundary. So permission boundary only allows access to DynamoDB, EC2, and IAM service. And IAM service is again list and read operation only. It does not allow access to S3 bucket. So permission boundary is or defines what is the maximum limit or what is the maximum operation which a user can perform. So irrespective of all of the policies which we have configured in here, we can impose a restriction with the help of permission boundary. Yes, it is an implicit deny. So it's like, again, inclusion, right? So based on the inclusion, it has to be all of the services which are included in here will only be allowed. So let's say if we have a access which is mentioned in here, but it is not in here, it won't be accessible. Yes, that is correct. It is like an AND. So we'll take a look at the graphs in just a minute. Now, this is again, so is this part clear? Why permission boundary or why user Bob is not able to access other services apart from the one mentioned in the permission boundary? So any doubts so far in this session? Okay, so let me go back in here. So when we created the IAM role Bob, we set a policy, right? We set administrator access, and we also set the trust relationship, which is again the trust policy. We allowed this specific user to access the AWS or to assume the AWS IAM role. So here, what we are going to do next is, and next what we did was we attached a IAM policy, which was by the name of Bob. And Bob basically allowed access to DynamoDB, EC2, and IAM service. IAM service only allowed list and read operation. It did not allow any sort of write operation, but DynamoDB and EC2 service has full access operation. Now, due to the presence of permission boundary, this specific policy does not have full effect. This is because, think of it like this one. So let me quickly show the diagram in here. I think it's in here. Yeah, this one. So as you can notice, this is an IAM identity-based policy, right? At this point, we had attached administrator access. But in the permission boundary, we only allowed EC2, DynamoDB, and IAM service. So only the intersection of the permission boundary and this specific policy will be allowed. Apart from that, all other operation will be denied. So at this point, with the administrator access, we are trying to interact with S3 service, but this is not included in here, right? So that's why we cannot access all of these services. So this is to answer the question of nullify. But if a boundary says you can access something, but you don't have the permission, you won't have access. Yes, that is correct. It has to be, again, intersection, right? So this has to include the access to a specific service, otherwise it won't be accessible. So this is to answer the question of Reza. Would you recommend admins not to do this permission boundary, just create policy that is specific to it? No. I'll actually recommend setting up permission boundaries as well as creating an policy. This is, again, permission boundary is an advanced concept which is placed to prevent privilege escalation. And many times what will happen is, again, what the administrator can do is create a permission boundary which do not allow any kind of privileged permission, and then the administrator can go ahead, create out the policy. So can you please elaborate? So this is to answer the question of CS Mukasa. Using the same name Bob for policy in the role made it more difficult to understand boundary and policy. Okay, I apologize for that one. I thought it would be easier to understand that. That's why I kept the name of the policy and the role as well. I should have changed it to Bob policy and Bob role. So any doubts in the permission boundary? Anyone? Okay, that's great. So let's go back in here. Now, when we are talking about IAM based policy, there are two variations. We have managed policy, we have inline policy. In case of managed policy, it's a standalone policy and it can be attached to multiple users, group, roles in the AWS account. There are two types. We have AWS managed policy, we have customer managed policy. Each policy has an ARN and has a version ID. Now, in case of inline policy, it is directly attached to IAM users, group, and role. Now, if you take a look at the JSON policy structure, we have the optional top level statement, then we have the statement which indicates or defines the access. Now, each statement has a couple of components. We have SID, effect, principal, action, resource, condition block. So the version is, again, the version of the policy language. The latest is 2012 October 17. And the statement is a container for various statements. And the SID is an optional ID which is used to uniquely identify a statement inside a policy. Effect defines whether it is an allow or deny. And principal is basically the user, the role, or federated user to whom the policy applies. Now, please note there are two kinds of policy, right? We have seen IAM policies which are attached to IAM roles, users, and all of these, right? Now, there is one more policy. Let me quickly go back to the slide and draw this one out real quick. So we have an individual, right? So this can be a principal. So this is a principal, right, who's trying to access a resource. So in order to access the resource, we can have IAM policy, which is, again, attached to the individual, or we can have something called resource policy, which is attached to a resource. Now, whenever we are creating an IAM policy, since it is attached to the principal, we do not have to mention the principal in the IAM policy. So there is no principal in here. There is no principal in here. But in case of resource policy, as it is not attached to any IAM principal, we need to mention the principal in the resource policy. So principal has to be mentioned in the resource policy. Now, if we'll take a look at the IAM role, so let me go back to the IAM role section in here, and let's select this one. So here you can notice that we have a principal field, right? So this specific entity, which is IAM role, is the only IAM entity which supports resource policy as well as IAM based policy. So IAM based policy is used to provide access, and the trust relationship actually uses resource based policy to define who all can access the or assume the role. So this is again the principal. Principal cannot be mentioned in the IAM policy. This is very important. Principal is only mentioned in resource-based policy. The action is the list of action that the policy allows and denies, and resources are the resources on which the action is to be performed. Conditions is just the additional conditions which are used to check whether access is to be allowed or denied. So here is one example. So we have a very simple IAM access policy, which says all operation on access key, right? So this can be get, list, delete, whatnot. All operation on access key. So we have two wildcard mentioned in here. And the resources, again, the account ID and user. So all operation on access keys of all of the users. This is again, this is what the policy dictates. Now this is another condition which we have in here. So this operation, allow operation on all access key operation is only allowed if this condition matches. So if you'll remember, we had set the tag for a specific role, right? Or specific IAM user. So this is again the principal tag. So this says that this principal tag of the key job category has to match IAM user admin. Only then this will be allowed. So this kind of restriction can be imposed with the condition block. So this says that the IAM principal, which has the tag job category and has the value IAM admin, can perform all access key based operation on all of the users. If a principal does not have this option, he or she won't be able to do that. Now this is again one such example policy where we are allowing access to S3, again allowing users to change password. And here you can notice the condition is set to multi-factor auth present, right? If this is true, only then the user can go ahead and interact with the specific S3 bucket. Apart from that, they won't be able to access the S3 bucket. So these are the condition-based restriction which we have in here. Now, here you can notice this is a IAM based policy because it does not have any principal attached to it. And this is a resource based policy. This is because we have a principal mentioned in here. So this specific policy is actually attached to an S3 bucket, and this is attached to an IAM user. Apologize for my drawing. I know it's horrible, but again, I can't help it. I'm working on improving it, but it will take me some time. So this is again the AWS managed policies. The important thing to note in case of AWS managed policy is that it is not granular. It is generic in nature, right? It does not mention the granular resources. So due to that, we have to create the custom managed policy or customer managed policy. So here again, the difference is that we can go ahead, customize all of these checks, right? We can customize it according to us. And this way we can apply granularity. Now here you can notice this is a very specific resource. We have the account ID, region name, the name of the function to apply the granular restrictions. Inline policy, the important thing to note is it is applied to IAM entity. It cannot be applied to multiple entities. We'll have to create an inline policy for each of them or opt for a customer managed policy. Now, resource-based policies are applied to resources. It grants the specified principal permission to perform the specific action, and it is used to perform cross-account, or it is used to provide cross-account access. So let's say we have IAM policy, right? Now we know that IAM policy is attached to principal. Now let's say we have two principal in different accounts, right? So let's say this is one account, this is second account. So with IAM policies, we cannot allow organize or allow a principal of one account to access the other account, right? So let's say we have a resource in here. What we can do is, with resource-based policy, we can mention that this specific principal can access this specific resource. So cross-account access can be allowed with resource-based policy, but we cannot do the same with IAM-based policy. In case of account delegation, again, we have to use the concept of role, right? So let's say we have two AWS organization in here. There are some resources in here. We need to have a role, which is again assumed by this specific, again, user or the principal. And from there, we can again access the resource. This is one way to do it. Here, what we'll have to do is again have IAM managed policy, which can perform or which can assume a role. And here we'll have to have the trust relationship, which allows this specific principal to assume the role. So this is again one way to do it with IAM based access, which is again we can go ahead, create a role, trust policies and whatnot. And here you can notice the trust policy itself is a resource-based policy, right? So this is a resource-based policy. So in turn, we are relying on resource-based policy for providing cross account access. So this is an example of resource-based policy. And this is an example of resource-based policy with condition. Now, can anyone tell me what exactly is this string? Anyone? So this is not exactly an access ID. So every IAM user, IAM role have a unique identifier. So in this case, this is user ID. In case of role, it is again role ID. So this string uniquely identifies a specific role. This is actually the role ID of a role. So we'll talk about this specific one later on, is the week 5, where we'll take a look at S3. So it will clear up back then. This is basically the role ID. So let me quickly go and yeah. So just to explain this part, so what we are doing is we have a deny statement in here, and it says that the get and list operation are denied on this S3 bucket, except, so as you can notice, we have string not equals, right? And it says that if this string matches, then this policy won't be applied. For all of the other user ID, this deny statement will be applied. So let's say we have individuals in here who are trying to access this resource, and we have role in here who's trying to access this resource. The role with this specific user ID can only access this resource. Others cannot access the resource. So this policy basically imposes this restriction. Now let me quickly go back to the IAM. So now, as you can notice, I am currently logged in as Bob. Now we do have access to EC2 service, right? So user Bob can access EC2 service. So it would be possible for me to answer all of the questions. So in case if I'm missing out some of the question, you can go ahead, paste the same in the questions for later section. And then after the session, I'll answer your question. So here, again, I think I have one instance running. So now user Bob has access to EC2 service, DynamoDB, as well as IAM service, right? So now let's try to create a very simple EC2 instance. So now please note, this specific user has full access on the EC2 service. So what I'm going to do is select Amazon Linux 2 AMI. So how many of you have created EC2 instances? Anyone? Oh, so how many of you have not created EC2 instances? Okay, so let me quickly go through this one again. So it's very simple interface. We can go ahead, click on launch instances. We have to select an image. So in this case, I'm going to use Amazon Linux 2 AMI. And now please note, whenever you're using your own personal account, you'll see such kind of symbol, free tier eligible, right? If you're using some other one which does not have this specific tag, that means you will incur charges, right? So please make sure whenever you're using AWS account and you have the free tier, please select these instances only. So I'm going to click on select. And now I have to select the type of instances. So as you can notice, T2 Micro is again free tier eligible. I'm going to click on review and launch. And again, I'm going to click on launch. I have to select a key pair and I'm going to select proceed without a key pair and click on launch instances. Now it failed, right? So, but we do have full access on EC2 service. We have full access. Can anyone tell me why this is failing? It was not supposed to fail, right? Why is it failing? It says you're not authorized to perform this operation. In the IAM, so let me go back in here. IAM itself says that, okay, permission boundary allows full access on EC2 instance. So we'll go back to the roles. Let me click on Bob. The permission boundary, again, I have administrator access, and here it says that EC2 full access, right? So the permission boundary actually allows the access. And here I have administrator access. If I'll scroll up in here, this is again administrator access. And here we have EC2 full access. So can anyone tell me why this is not working? Why did it fail? So in this case, we do not have any resource policy. In case of EC2, we do not have resource policy. So let me go back to the review screen. Let me change the instance type. Let me select T2 small. And so what I'm doing right now is changing the instance type from T2 micro to T2 small. And I'm going to click on review launch, click on launch back again, and proceed without a key pair, click on launch instances. And now it succeeded, right? It says your instances are now launching. So why did it not work in the previous case? Anyone? Yes, that is correct. There is a concept called SCP. So at this point, let me go back in here. Here we can notice we have administrator access policy, we have permission boundary. And all of these things, policy, roles, users, all of these reside within an AWS account, right? So let me go back in here. So all of the roles, users, group, policies, all of these reside within an AWS account. So at this point, as an attacker, if you're not aware of concept of an organization, you will keep wondering that why is it not working? You will try a couple of things out. You'll probably again wonder that probably AWS is broken and why it is not working, right? So this is where concept of AWS organization comes into the picture. So when we are creating an AWS account, we have an option to create an AWS organization, or we can be part of an AWS organization. So every AWS organization has a root, and every AWS organization has a management account. Now we can go ahead, create something called organizational unit and arrange various AWS account inside these organizational unit. So at this point, we have noticed that we have IAM, users, groups, we have roles, policies, right? All of these reside inside the AWS account, which is this one. Now, there's something called SCP, which resides outside of the AWS account. So there is no way from within this AWS account, you can see this one. You cannot do that. Only the management account can go ahead, view these policy. A member account cannot view the policies which are outside of the AWS account, which is the SCP. Now these policy, just a second. Now these policy will define the restriction. So at this point, what I have done is I have a policy which denies or denies certain EC2 operation, right? So due to which we were not able to start the instances. So this was the SCP which I had in place. So is it visible, or I think it is blurred, right? Let me quickly enlarge this one. I'm not sure why is it appearing blurry, but here you can notice we have T2 small mentioned in here, right? So it says deny on run instances operation. This is the resource. And here it says string not equals T2 small. So any instance type which is not equal to T2 small. So initially we selected T2 micro. So this is not equal to T2 small. So what happens is the run instance operation is denied. This condition completely turns to true. So that's why we were not able to start a T2 micro based instance. We were only able to launch a T2 small instance. So this is again the restriction which is imposed with service control policy. So if an attacker is not aware of the concept of organization, you'll probably keep wondering that, okay, why is it not working, right? So this is very important to know. Many times when you're performing certain operation, you will notice that it is not, we cannot perform those operations. So whenever this is the case, you have to speculate that probably there is an SCP which is acting on the organization unit or on the member account, which is preventing this kind of operation. So there is no direct way to find out about SCP. It's like completely outside the AWS account. All you'll have to do is perform various operations to identify whether it is allowed or disabled. And that's the only way.